Ready? Question number 11. A current carrying circular loop lies on a smooth horizontal plane. Can an uniform magnetic field be set up in such a manner that the loop turns around itself, that is, turns about vertical axis? Okay. Turns about vertical axis. There will be a torque according to this question. Yes. First, we'll write the formula for torque. Tau equal to m cross b. Here, torque toe is always perpendicular to m. That is the first point. Same way, torque is also perpendicular to magnetic field. Now, here in the question, the coil is kept horizontal, right? This is the coil. Now, suppose the current is flowing in this direction. Magnetic dipole moment is vertically upward, right? This is suppose clockwise or anti-clockwise, upward or downward. Now, I'll take it is in the anti-clockwise direction. Then magnetic dipole moment will be upward. If magnetic dipole moment is upward, how the torque will be upward? Not possible, because according to this formula, toe should be perpendicular to M. Here, M is already vertical, means it is perpendicular to the coil. This means the loop cannot rotate about its own vertical axis. If so, then what happens? Toe and M parallel, toe and M, it never become parallel, so it is not possible. We'll go for the second question. A current carrying circular loop is located in a uniform external field. If the loop is free to turn, what is the orientation of stable equilibrium? Okay. Potential energy is minus of m dot b or minus mb cos theta. In stable equilibrium position, energy should be minimum. Please keep in the mind, minimum energy means theta equal to 0. Cos 0 value is 1 minus mb. The energy, minimum energy is minus mb when theta equal to 0. When theta equal to 0, but in the question, what is the orientation? Theta equal to 0. What is theta? Theta is angle between M and B. So, same way, the loop is horizontal. Loop is kept like this. Magnetic field is, magnetic dipole moment is upward. Magnetic field is also upward. In other words, magnetic moment and B are parallel. Magnetic moment M and magnetic field B both are parallel. Stable equilibrium, that is plane of the loop is perpendicular to B. Magnetic moment and magnetic field both are parallel, that is plane of the loop is perpendicular to magnetic field. We'll go for the last part. A loop of irregular shape carrying current is located in an external magnetic field. If the wire is flexible, why does it change to a circular loop? Yes. When a current is flowing in a loop, which is kept under the uniform magnetic field, each small segment of the wire experiences magnetic force. This force actually acts radially outward. There will be an outward pull on each and every segment. So what happens if the loop is irregular? Each and every part will be pulled outward. So as a result, it becomes circular. That is, an irregular loop experiences outward force at each and every point. And because of this force, irregular shape becomes a circular, hence enclosing maximum area as well as maximum flux.